So now at A there is a hinge is there. There are two reactions RAH and RAV. At B only roller support is there, so only single reactions RB. Now to find out these 1, 2 and 3 reactions, we have to use the 3 equilibrium conditions. The number 1, sigma H is equal to 0. As such, there is not a single horizontal force which is acting on this particular body, so RAH is equal to 0. Next, take sigma V is equal to 0. Sum of all the vertical component of forces are equated with 0. As per that, the first RAV is acting upward and RB is acting upward. These two forces, we are assuming that these two forces are acting upward. So RAV plus RB is equal to, because all other forces are acting downward, is equal to this point load, that is of 20 kilonewton plus 50 into total distance 3 plus 1.5, 4.5. And we got RAV plus RB is equal to 245 kilonewton. As we discussed earlier, that sigma V is equal to 0, we will achieve an equation which correlates between these two reactions. To find out individual reaction, we have to take a moment at a certain point. So now let us take a moment about A point, which is equated with 0, that is sigma MA is equal to 0. So RAH into 0 it is 0, RAV into 0 it is 0. Why? Because perpendicular distance is 0. So now the first force, this 20 into 1, that is plus sign because creates the clockwise moment, 20 into 1. Another force which is of 50. This 50 kilonewton per meter, which is the UDL. So 50 into 4.5 is the total load multiplied by 4.5 by 2, that is the CG distance to this distance, plus this one, that is 1.2 plus 1, that is the 2.2. Another force which is of RB, so minus RB into 5.2. Why 5.2? Because 3 plus 1 4, 4 plus 1 5.2, 5.2. So 5 plus 0.2, that is 5.2, is equated with 0, and by solving this we get RB is equal to 196.39 kilonewton. By putting the value of RB in this equation, we get RAV is equal to 48.61 kilonewton. Now, by knowing all the 3 reactions, we have to plot the shear force diagram and bending moment diagram using the basic concept. Let us go to the tabletop over here right now. Here, the given beam, which is of this kind, overhanging beam, (20 kilonewton), 50 kilonewton per meter. These reactions that we achieve, that is of 48.61, 196.39. This distance are of 1 meter, 1.2 meter, 3 meter and 1.5 meter. This is my baseline. Now, next, Before we are going to take a section method, let us use our fundamental concept and let us plot the shear force diagram. Let us plot the shear force diagram. Reaction itself gives the value of shear force. So this ordinate comes to be 48.61. Between, this is A point, this is B, so this is C, D and E. Between A and D there is no load, means the variation of shear force is given by horizontal straight line. At D point sudden change will be there, that is of 20, and if we take a section, it is downward 20, section downward 20 taken as negative. So 48.61 minus 20, that we got it 28.61. So we got over here as 28.61. Now between D and E there is no load, variation is given by inclined straight line. Next, at B point, because between E and D only a single load is there, that is of UDL, we know the variation of the shear force is given by inclined straight line. Only our intention is to find out the ordinate. What is the ordinate at B? Just left. Then if we take shear force at B just left is equal to 48.61 minus 20 minus 50 into 3, minus 50 into 3, because distance which is of 3 meter, and we got it minus 121.39. So we achieve this ordinate is of 121.39, and there is a UDL which is joined by inclined straight line. If we take just right of B, then this load will be come into the picture. So shear force at B just right is equal to minus 121.39 plus 196.39, and we achieve as if plus 75. So at this point load, this variation is of plus sign. At C point, obviously the value of bending shear force is 0. Let us check. Shear force at C is equal to plus 75 minus 50 into 1.5, and this comes to be 0, and there is a UDL. Join these 2 points by inclined straight line. So we get, this is inclined straight line, these two are straight line, positive sign, minus sign, positive sign. And this diagram is known as shear force diagram. You can plot the same shear force diagram by taking the basic concepts of section. Means you have to take a section over here. You have to find out the variation at A and D. You have to plot it out. You have to take a second section over here because one load is over here is there. You have to find out the variation between D and E. Then you have to take a sections over here, and you have to find out the variation C and B. Definitely you can do it. Now this point is very much interesting for us. It is known as obviously the point of zero shear, that point at which the shear force is 0, we can achieve maximum bending moment. Let this distance is x, so this distance is of 3 minus x. as this relationship is of inclined straight line, we can use the basic concept of mathematics that this angle is theta, that angle is also theta, tan theta is equal to opposite side by nearest side. And now this is a basic equation we can get x is equal to 2.43 meter. So we found x is equal to 2.43 meter. So this ordinate is of 0.57 meter. Now let us plot. After finding out the shear force diagram, let us go for bending moment diagram. Given beam, overhanging, point load of 20 kilonewton, distance are of 1 meter, 1.2 meter, 3 meter, 1.5 meter. The important points where we found out the values and then join those points to achieve bending moment diagram. Baseline. All the positive values are above baseline, all the negative values are below baseline. As for that, A, B, C, D and E. Now at A point, because there is not a beam from the A side, it is starting beam from A, the value of bending moment is 0. Let us find out at D. Bending moment at D is equal to 48.61 into 1 and we achieve as of 48.61 kilonewton into meter. Plus sign, section left clockwise, positive. There is no load between A and D. It has been joined by inclined straight line. This ordinate we achieve 48.61. It is this ordinate. Next, at E point, bending moment at E is equal to 48.61 minus into 1 plus 1.2 minus 20 into 1.2 is equal to, if you will simplify this one, we achieve 82.94. So we achieve as if 82.94. Next, our next intention, because this is the point F point, distance from E is of 0.57 meter, where we get maximum bending moment. So bending moment at F is equal to 48.61 into 1 plus 1.2 plus 0.57 minus 20 into 1.2 plus 0.57 minus 50 into 0.57 into 0.57 by 2. By simplifying this, we get the answer 91.13 kilonewton into meter. So we HU maximum value is of 91.13. Visualize the UDL has been given to you. It has been shown by parabolic nature, not a straight line. It is a parabola. Now at B, bending moment at B is equal to 48.61 into 1 plus 1.2, that is of 2.2, 2.2 plus 3, 5.2, minus 20 into 1.2 plus 3, 4.2, minus 50 into 3 square by 2, why 3 square? 50 into 3 into 3 by 2, and we get it out as 56 minus sign 0.25. Minus sign means it is below baseline, 56 over here, and this has been joined by parabolic nature. This ordinate is of 56.25. At C, obviously it is 0. We know in the previous case it has been joined like this. You can find out the central ordinate over here, the value also. If we get the point G, then bending moment at G, if we take a right side section, in this case minus 50 into distance is of 1.5 by 2 into 1.5 by 2 by 2, and we find out certain ordinate. It is this over here. Next, intention is to find out this point. What is this point? This point is known as point of contraflexion, and we can find out by taking a section. I wish you can do by yourself. Please note down the answer is 4.68 meter. Find out the concept of section by taking a section over here, equated with 0, we find out 4.68. If you want to take an equation, bending moment, because you just visualize this, 0 bending moment is taken place between E and B.